I'm really happy to present you today one of the most exciting products you have ever seen. Any idea? Let's listen to a very special guest first.
Insane cornering, really direct cornering, and if you accelerate, you feel the whole energy, whole power goes into the forward movement.
It's time to reveal our all-new road wheels range with on top of it the Capital SL, a one-piece carbon system that is lighter, stronger and more responsive. I'm here with Chris, he's product manager for the project. What was the background of this project and when did you decide to start on this new wheel set?
As you know, we launched successfully in 2018 the Civitan SL cross-country wheel set, which was our first one-piece carbon wheel set. We have won numerous World Cup wins with Nino. We also won the Olympic Games with Tom Pidcock on it. And we got a lot of questions from markets and end consumers when we will bring this concept to the road. Structural-wise, we could already take a lot of the Civitan SL development. The system for speed as a one-piece construction was already there. Then it was all about the different specs on the road, the different constraints, and obviously working on the Capital SL Aero, which is an aero-driven project. We had to take into account the aerodynamics, obviously.
Thank you, Chris. We are now going to move on a more technical detail with William, our lead engineer for the project.
A traditional wheel is a collection of parts. If you want to get the best wheel, you have to take the best rim, the best spokes and the best hubs. Capital SLs are developed as a system. The spokes are working perfectly with the rim and the rim is working perfectly with the spokes and the hubs. Our wheels are produced using our one-shot patented manufacturing technique inherited from the Civitan SL. From our manufacturing process, hub flanges, spokes and rims are coming as a one piece from the tool. Later on, we insert and glue a bearing tube in between the two hub flanges. This bearing tube has the interface for the disc and welcomes all the internals. A big part of our patented process is about the spoke pre-straining. An high-precision jig is pulling on the hub flanges before we insert the bearing tube. Our wheel design makes the best use of the carbon fiber mechanical properties. At synchros, speed means first low weight and inertia, second low aerodynamic drag, and better handling and ride character. On top of that, we did not forget about the rolling resistance. We consider the tire as well in part of the development of the system. From the start of the development, we took into consideration the potential negative effect of a bigger tire in terms of aerodynamics. The internal widths of 23 and 25 mm are the best compromise in terms of rolling resistance and aerodynamic performance. Let's now move to the aerodynamic optimization, and for this, let's listen to Jan, our aerodynamic expert.
From the Civitan SL wheels, we knew how to build a lightweight and structurally strong wheel. For Capital SL and Capital SL Aero, we had to add the efficiency aspect, which is a combination of the aerodynamic performance and also the rolling resistance. We also wanted to make sure that not only the translational drag, which is what the wheel sees from moving through the air, but also the rotational component is considered. So we built a system that can be installed in the wind tunnel that consists of a small electric motor that drives the wheel, and in between we have a torque sensor to measure the torque required to keep the wheel running at a constant speed. From this measurement we can then calculate the rotational drag. Going to the wind tunnel, we knew that we wanted to compare different rim shapes, and therefore we started the development of a modular concept that allowed us to test these different shapes quickly and in a cost-efficient manner. Another important reason for testing in the wind tunnel is that you can have the real tires mounted on the wheel and optimize the system of wheel and tire together.
So now, let's look at the Capital SL Aero wind tunnel results when it's fitted with 25C Schwalbe Pro 1 TLE tires. The red curve shows that the aerodynamic performance of the wheels is very good. It's always better than any of the benchmark wheels. If we zoom closer to the 15-degree yaw angle, we can see that the flow is detaching much later than the benchmark, which results in a better crosswind stability. As you can see from this graph, the 25C and the 28C tires behave nearly the same. As a result, we decided to specify the 28C tire even on the front wheel. Let's look at the shallower profile, the Capital SL. On Capital SL, we decided to compromise a little bit the aero performance versus the weight optimization. Still, we took the wheels into the wind tunnel and checked how they performed. They were still 7% faster than the closest in the benchmark. We even decided to compare our Capital SL wheels to deeper cross-sections. We brought them in the tunnel and compared to 60 mm rim depths. As you can see, they perform nearly the same. The main advantage is that they will be more stable and better in terms of handling. Let's now move into the structural development with one of our engineers, Massimo.
The goal of the development of these wheels was to maximize the overall efficiency of the system, and this means accounting at the same time weight minimization, aero performance maximization, and rolling resistance tuning. A combination of these objectives leads to the maximum power transmission from the rider to the road. Since the beginning of the Capital SL and SL Aero project, we had in mind the possibility of making these wheels gravel compatible, and therefore we chose design parameters that are suitable for this, as the internal width, the spoke number and the spoke distribution, and the spoke strength. The wheel layup optimization makes extensive use of finite element simulations with the goal of maximizing the safety ratio of the wheels. To record real-world data, we have to equip this bike on the right with the sensors, and for this we had to modify the dropouts of the bike to include sensors in the hub region. Through a lab calibration procedure, we are able to translate those strains into loads that are applied on the rim. To be efficient in the development process of the wheel, we combine the real-world data measurements with lab testing happening here in this workshop and at our partners' facilities. We can do both destructive and non-destructive tests. On the destructive side, we can do UCI impact tests, but also custom tests. And on the non-destructive side, we have lateral stiffness and radial stiffness. We can also perform cycling fatigue tests as well as braking tests, and this happens at our manufacturing partner facilities.
The development target was the weight. We did not forget about rotational inertia. Rotational inertia is the energy which is needed to spin the wheel. To reduce this energy, we have to bring the weight from the rim closer to the hub. It makes the wheel easier to accelerate. We made an extensive use of FE. We brought the wheels into the lab for static and fatigue testing, but on top of that, we spent many hours on the bike collecting thousands of kilometers.
What does that mean for you on the road? A faster acceleration, a faster cornering, a better handling and aero performance at just 1,170 grams for the Capital SL and 1,290 grams for the Capital SL Aero. The range consists of two models, the SL Aero with the 60 mm rim depth and the SL with the 40 mm rim depth. We also offer the 1.0S and 1.0 levels, which are a lightweight alternative of the Capital SL with the same carbon fiber rim laced with DT Swiss hubs for the 1.0S and Syncros hubs for the 1.0. If you want to know even more about our new Capital SL, head over to our website. Thanks a lot for your attention and see you on the road.